Section 13.2 is about angles and angle measures. The initial side when we're talking about an angle is the fixed ray along the positive x-axis, and that can be seen right here. And then the terminal side is the other ray of the angle. That's where my angle ends, that's over here. Now, this arrow describes the direction of my angle, which is very important. Standard position is the angle position so that the vertex is always at the origin and the initial side is always along the positive x-axis. And that is how we will get used to working with these angles. Now, the positive x-axis is known as 0 degrees. The positive y-axis is 90 degrees. The negative x-axis is 180 degrees. The negative y-axis is 270 degrees. And then back at 0 is also 360 degrees. This is how we will label when we're dealing with an angle in standard position. Positive angle measures go counterclockwise. That's why that red arrow is super important. Negative angles go clockwise. When we're dealing with negative angles, we label slightly different. We still start at 0, but the negative y becomes negative 90. The negative x becomes negative 180. The positive y becomes negative 270. And then back at 0 is negative 360. Okay, so that's just slightly different. When terminal sides rotate, they must make one or more revolutions. An angle whose terminal side has made exactly one revolution has a measure of 360 degrees. Okay, for example, let's suppose my angle's here, but it went fully around my circle and then ended there. So draw an angle with the given measures in standard position. Well, since this is 180 degrees, and this is 270, then 240 is about 30 degrees from 270, and it's positive, so it goes that way. Negative 30, well, this is negative 90. This is 0. So negative 30 is only about 30 degrees past 0, moving in the negative direction. And the last one, 450. Well, 450 goes around more than once. So I'm going to subtract out one rotation, and I end up with 90. So the initial side is there. The terminal side is going to be at 90. But when I draw my arrow, it goes around once and then goes up to 90. A radian is a unit to measure angles. It's just a different measure of units. It's just like if you use feet versus inches. A unit circle is a circle of radius 1 whose center is at the origin of a coordinate system. Okay, for example, this is an example of a unit circle. 1 radian is the measure of an angle in standard position whose rays intercept an arc of length 1 unit on the unit circle. Most of the way we're not going to be thinking about radians in that aspect. Instead, we're going to be thinking about radians in terms of this aspect. We know the circumference of any circle is 2 pi r. We learned that in geometry, where r is my radius. So the circumference of my unit circle is just 2 pi, since my r is 1. This angle measures 360 degrees because every circle is 360 degrees. Therefore, 2 pi equals 360 degrees. Therefore, I know that there are 180 degrees in pi radians. So what we're going to use is we're going to generally think about radians in terms of these two conversions. So these two conversion rates will help me convert between degrees and radians. Rewrite the degree measure in terms of radians and the radian measure in terms of degrees. So 60 degrees, what I'm going to use is I'm going to put pi radians on the top and 180 degrees on the bottom. This way, my degree units cancel, my zeros cancel, and then my 18 and 6 are both divisible by 6, so this becomes 1, and that becomes 3. So then when I multiply across, I get pi over 3 radians. In example 2, this time I have negative 7 pi over 4. So that is technically in terms of radians. So I'm going to multiply it by 180 degrees over pi radians. So this time the radians will cancel, as well as the pi's will cancel. Then 4 and 180 are both divisible by 2, so I get 90 and 2. And they're both divisible by 2 again, so I get 1 and 45. So then I multiply negative 7 times 45, so I get negative 315 degrees. This must be memorized. What this is this is all the important degrees that we will take a look at with respect to my unit circle. Okay, so this is a unit circle, which means the radiuses are 1. So these are all the important degrees, as well as all the degrees in terms of radians. So we want both units of measures for this circle. Coterminal angles are two angles in standard position that have the same terminal side. For example, in this picture, 45 degrees is the green angle, and then 405 degrees is the red angle. But if you notice, they both start and end at the same spot. All they do is they differ by a multiple of 360 or 2 pi, if we're talking in terms of radians. Okay, so they would have the same value because they start and end at the same spot. So if I want to find one angle with positive measure and one angle with a negative measure, coterminal with each of these angles. So for 240 degrees, what I can do is I can add 360 to that, and I get 600 degrees. So 600 degrees would be the same as 240, and then I can take 240 and subtract out 360 degrees, and I get negative 120 degrees. So these would be coterminal angles for 240 degrees. Now with 9 pi over 4, I'm going to do 9 pi over 4 plus 2 pi. Now remember, when we add fractions, we need a common denominator. So I'm going to change that to 8 pi over 4. So I get 17 pi over 4. Okay. Then when I subtract 9 pi over 4 minus the 8 pi over 4, I get pi over 4. Okay, so both of these are coterminal angles with 9 pi over 4, but the direction says I need one positive and one negative. So what I can do is I can take the smallest one, which is pi over 4, and I can subtract out another rotation. So I end up with negative 7 pi over 4. So either positive one would be correct, and the negative one must also be included.